It was requested that I put a video on about friction because there is not one on friction, so that this will help you review some of the concepts we've discussed. So when you have friction, you can imagine a block of some sort sitting on a table, and that you're trying to pull this block with a force F. And if the block is stationary, then you have static friction if it's stationary. Alright, so that means that if you were not going to pull the block with any force, let me erase this. If the block's just sitting on a horizontal surface and you're to sketch the forces acting on it, all I would have would be the normal force and the force due to gravity. And I'd have the potential for friction to exist, but there is no friction force yet until I start to put a force on it. When I start to try to pull the object here with a force F, the friction is going to resist that. And so I'll get an equivalent static friction force here that's going to resist me pulling it. Now the size of the static friction force is going to be dependent upon how hard I'm pulling it. But there is a breaking point, and that's the point we're interested in. The breaking point happens when F is greater than the maximum value that the static friction force can achieve, and that's when the object will start to move. So I'll say greater than or equal to. Alright, so when that happens, then you'll have the object starting to move, but let's try to figure out what is this Fs max? What's the maximum static friction that an object can have? Slide for this. And basically what we're saying is that an object sitting on a surface of some sort, there's a coefficient of friction between the object here. This is a static coefficient of friction. That's a unitless quantity. That's bigger when you have a rougher surface, typically, on one or both of the objects. And then there's the normal force that you already know about. So the force due to static friction, the maximum force due to static friction, by definition, is equal to the coefficient of static friction times the normal force. So the more normal force the object has on it, the greater the friction is going to be. The greater the coefficient of static friction on the object, the greater the static friction could become. So the normal force then, what influences this? Well, the weight of the object certainly influences this. So an object that has a greater mass, I should say the mass, which greater mass means greater weight. Greater mass is going to result in greater mass implies greater weight implies greater normal force. And if the object's horizontal, then the weight is equal to the normal force. The other thing is if I stacked stuff on this object, if I put stuff on top of it, I'm going to increase the normal force of the object without increasing its weight. Okay, so this is just a little review. Just wanted to give that plug on static friction, and I'll give you another video on kinetic friction.